Okay, so we're talking about the tap rules, and the 10-foot tap rule begins with if the wire is less than 10 feet and the load is smaller than the tap rule conductor, which means what? If the tap rule minimum is smaller than the actual load, then you have to use wire to accommodate the load. I've said that a couple times, but it seems like that just didn't stick very well. David, would you be so kind as to read the next paragraph, please?
B. Not less than the rating of the device supplied by the tap conductors or not less than the rating of the overcurrent protective device at the termination of the tap conductors. And 2. The tap conductors do not extend beyond the switchboard, panel board, disconnecting means, or control devices they supply.
So where we're talking about a disconnect, where we're supplying a motor branch circuit, the wires cannot go beyond that disconnect. They've got to terminate in the disconnect. All right.
The tap conductors are enclosed in a raceway, which shall extend from the tap to the enclosure of an enclosed switchboard, panel board, or control devices, or to the back of an open switchboard.
So what that means is that it has to be in a conduit or a raceway. It can't just be sitting open, going down to the disconnect. Okay, it can be open in an auxiliary gutter or a wireway, whatever you'd like to call it, where it's tapped to the feeders. Okay, and the next rule is?
For field installations where the tap conductors leave the enclosure or vault in which the tap is made, the rating of the overcurrent device on the line side of the tap conductors shall not exceed 10 times the ampacity of the tap conductor.
So what that's saying is that these conductors must be able to carry at least 10% of the overcurrent protection device, a primary overcurrent protection device. All right? And that's why we call it the 10% 10-foot tap rule. All right. Is that the last thing?
Yeah.
All right. So let's go on to the 25-foot tap rule. Go ahead.
Taps not over 25 feet long, where the length of the tap conductors does not exceed 25 feet, and the tap conductors comply with all of the following. 1. The ampacity of the tap conductors is not less than 1/3 of the rating of the overcurrent device protecting the feeder conductor.
So far, the only thing different is the percentage. So the conductor has to carry at least 1/3 of the primary overcurrent protection device ampacity. Is that correct? Okay. Go on to the next one.
2. The tap conductors terminate in a single circuit breaker or a single set of fuses that limit the load to the ampacity of the tap conductor. This device shall be permitted to supply any number of additional overcurrent devices on its low side. 3. The tap conductors are protected by physical damage by being enclosed in an approved raceway or by other approved means.
So it's got to be in a conduit or a raceway. And our next rule says?
With 3, taps supplying a transformer, primary plus secondary not over 25 feet, where the tap conductors supply a transformer and comply with all of the following conditions.
Okay, so this one is for transformers, which we're going to talk about later, but it's the same set of rules, right? Just say yes.
Yes.
Okay. It is. It's the same set of rules for the 25-foot tap rule if you're feeding a transformer instead of a switchgear or a. All right, so the next thing we want to talk about is we want to talk about selecting the motor starters and the motor overload heaters. And this is the one place where I said several times before that we're going to use the codebook calculations for everything except the overload heaters. And this is that one exception. So now we've got to first size the motor starters. And in the front, the very first page of your pink handout, take a look at that. And remember that we're looking at a 460 set of motors. So let's go down the horsepower rating on the far right because it's polyphase. And we're going to go down to a 5 horsepower. And we're going to find our 460. We're going to go down the right column to our 5 horsepower. And you'll notice that they're in the 1/0 and the 1 size starter. The 1/0 can be used because it says 460. If we slide across to the 460 voltage, we would select a 1/0. So our first motor, starter I should say, would be a 1/0 starter. Let's put that in. So it's a 1/0 size. We don't say 1/0 or 1/0 or 0. We say 1/0 because there's a 2/0 size which is even smaller. Okay, so now let's go over to the next starter, and it's a 10 horsepower. Take a look at that. And you can see on the far right column, if we go down to 10 horsepower, there's 2 in the 1 size and then 1 more down in the size 2. Now the 1P is for single phase motors only. You'll notice it only says 115 and 230. That means it's a single phase type starter only, a 1P. So let's go back to 460 and it says a size 1 will work. All right. Let's go over to our next one, and we'll see where it's only 7.5 horsepower. And at 7.5 horsepower, it's kind of confusing, right? And at 460, it can go up to 10. But at 460, down at 1/0, it's only 5. So we have to select the size 1 because although 460 is good up to 10, that will cover the 7.5, but the size 0, 1/0, will not. So we have to select the size 1. You'll see why this is really important in just a minute. Okay, so we're going to go to our last one, which is our biggest motor, 15 horsepower. And we're going to look at 15 horsepower. And you notice it jumps up to 25. In size 2 at 460. Can we go back down to size 1? No. Because at 460, the biggest one we could have on a size 1 starter is a 10 horsepower. So we have to go back up, and our 15 is smaller than 25, so we can use the number 2, but it would take care of all the way up to a 25 horsepower motor. All right, so we're going to put in a size 2, is that correct?
Yes, sir.
All right, so size 2. All right, now the next most difficult seeming thing to do is to select the overload heaters. Now the first thing is that you have to realize that there are a lot of different kinds of starters. Now we just picked the size of the starter only so far, correct?
Mm-hmm.
Okay, but we didn't pick the type. And if you go to the next page, I want you to notice on the back of the front page, back side of the first page, is a description of how to select the overload heater. These are called thermal units. The overload heaters, what we call overload heaters, are called thermal units. Okay, and the name of this little booklet is Thermal Unit Selection. So if we go to the back, it says the first thing to do is determine the motor data. Now where do we get the motor data? From the nameplate. Very good. Now we also have to find the service factor. The service factor, you'll notice down below the motors it says code B 1.15 SF, 50 degrees centigrade. It's talking about the efficiency of the motor, the service factor of the motor, which is how much it can be overloaded, and the temperature rise is rated for. So then we have to look at the service factor. Now, it says that for 1.15 to 1.25 service factor, use 100% of the motor full load current for thermal unit selection. Is that 100% of full load motor current from the code book? No, that's 100% of the full load amps on the nameplate. This is the only place we're going to look to the nameplate only. So 1.15 to 1.25. What does that 1.15 to 1.25 mean? That means that motor can be stressed beyond 100% of its full load capacity for a short period of time without doing damage to it. In other words, it's a well-built motor instead of a cheesy motor. Okay? So, if it's a 1.15, a 15% overload for a short period of time is not going to damage the motor. Or a 1.25, that means 25% overload, which is a lot, right? The wires inside the motor are insulated well enough that a 25% overload is not going to damage the windings. That's what that means. Okay? Very important factor, because when you get a short inside those windings, that motor is done. Right? There's nothing you can do about that. Everything else is kind of fixable. The bearings can be replaced. A lot of things can be replaced, but when you short a winding out, it's over. And that's what we really want to protect against, because the biggest enemy of any motor, any electrical device is heat. Heat destroys everything. Okay, now let's go back down to our thing, and it says 2. For 1.0 service factor motors, use 90% of the motor full load current for the thermal unit selection. In other words, thermal units are going to let it run a little bit over anyway, right? Up to 3 hours. It's a thermal inverse time relationship. And we know that it's going to let it run over a little. So if you want to stop it when it hits 100%, you're going to have a thermal unit that's only 90%, because no matter what, it's going to let it run a little over for up to 3 hours. Okay, depending on how long and how big the overload is, the overloads will trip it, depending on how much overload it is and how long it is. Okay, now it says motor and controller in different ambient temperatures. We're not going to worry about that. We're going to assume they're in the same ambient temperature. Then it says locate proper table from index pages 11.239 to 11.240. The proper thermal unit number will be found adjacent to the load current or resultant full load current falls. In other words, it just says go look up the number at the right table. So now let's go to the next page, and we'll see where it says starter type on our first page, which is 11.239. But I want you to note when you come down to AC magnetic starters, which is what we talk about most often in this class, right? We're talking about across the line, full load current starting starters, which are known as magnetic starters. And right below that it says small enclosure. Now there are times when you have to use a small enclosure because you just don't have very much room in the area you're putting this thing in. But generally speaking, we try and avoid doing that because smaller enclosure, not enough, it's not going to flow air as well. So let's go to the next page, 11.240. And if we go down to the same thing, it says, first one, it says AC magnetic starters, large enclosures. We like large enclosures, right?
Yep.
Because they are going to run cooler. They're going to help the environment of the disconnect operate, not the disconnect, the motor starter operate in a little bit of cooler environment. Now, there are different kinds. Now, some of them are the starter that's in a motor control center we call a bucket, and that is generally an 8536. Our book calls it a multi-motor panel. We call it a motor control center, and it's a bucket that slides in. It's got the disconnect, it's got the starter, it's got everything all in one unit. And then we have all these others that are independent little starters. And let's just pick one, and we're going to say that we're going to use an 8538. Now, all of these have slightly different characteristics, and we're not going to worry about that too much today. So let's just say we're going to use an 8536. No, let's not. There's an exception that I don't want to get into because we don't have any double-aught starters anyway, do we? We don't. Okay, so we can use an 8536. I mean 8538. We'll select an 8538 as what we're going to use for these starters. So now we're going to go back to our, look where it says type. It says A, SA, SB. Don't worry about that too much, but slide over until it says size. Oh, look at that. Double-aught, and it says, the first double-aught says 8536 only. Okay, so we're not talking about an 8536, are we? We're talking about an 8538, so that top one does not apply. And we don't have a double-aught anyway, but I just want you to notice this, that when it says that very top one, that's for a what's called a motor bucket only. Okay, so let's go down to 1-aught. So most of our, is it most of them? Are they all 1-aught? No. Let's see. We have a size 1. We have a 1-aught. We have another size 1, and we have a size 2. So we have one size 1-aught. Now, let's slide to the right, and the column we're always going to use, just in case you want to know, is the standard trip. And what does it say when you slide to the right? 15. What that means is chart 15. Okay? Let's go to chart 15. Turn over to the next page, which is 11245, and you'll find chart 15, upper right-hand corner. Now I want you to notice that it has 3 columns at the top of that chart. That chart says 1 TU, 2 TU, 3 TU. 1 unit, 1 thermal unit, 2 thermal unit, 3 thermal unit. This is a 3-phase motor, right? So it's a 3 thermal unit. Now let's look at our code book ampacity, which is 7.6. Is that what we're going to look up?
Same thing.
I'll tell you one thing, that's all, man. It's not in line.
Yeah, I know.
It's not the next page.
Recording. All right, so when you look at our first motor, and we have a nameplate full load ampacity of 7.25 amps. Now, its service factor is 1.15, so we are going to use the full 7.25 nameplate ampacity. I want you to notice that the codebook ampacity is higher than this, 7.6. On very few occasions, you may need to make a note of this, very few occasions, if the nameplate ampacity is higher than the codebook, then you must use the nameplate ampacity for everything. In the very few cases where the motor is made so poorly that its nameplate ampacity is higher than the codebook ampacity, then you need to use that number for everything because it's a really poorly made motor. We probably have a pretty good idea where that one was made. We got it at Harbor Freight, probably. Okay?
Radio Shack.
No, I don't think so. So we're going to use, are we going to take 90% of this 7.25 or are we going to use the whole thing? Per the instructions, we're going to find the full 100% nameplate ampacity in our chart. So we're going to use 7.25, and let's go over and look for 3 TUs that's where we're going to find the thermal unit where it has 7.25. And this is a range, so we have to look in the range here, and we have to go down, and it goes down to the second to the last set of columns. Starts out at 5.22 up to 5.51. And the second to the last one in that little group is 7.08 to 8.05. Everybody see that? What heater element is that? B11.5. That's correct, and that's what we're going to put right here. So the answer to this one is B11.5. That is the number of the heating element. You can order, this is a Square D booklet now, and we're ordering Square D starters, and you just tell them, with this size 1/0 starter, I want 3 B11.5 heaters. You're done. Okay, let's go to the next one. It's a size 1 starter, so now let's go back to the front page. We're going to use a large enclosure in this one. And we're going to go to size 1, and what chart does it say to go to? That's right, 15. So let's go back to 15. We were just there, so we're going to go right back to 15. We're still in 3 thermal units, but this time this is a 1.0 service factor. Everybody see that? Okay, our code book ampacity is 14 amps. Our nameplate is 13.5. Are we going to use either of those numbers to look it up? No. We're going to take the nameplate ampacity of 13.5 and we're going to take 90% of that. What is 90% of 13.5?
12.15.
Okay, 90% of that is 12.15 amps. So now we're going to use that 12.15 as our number. We're going to go back over to this column. We're going to find a number that's around 12.5. 12.15, I should say. No, you have to go down. The following selection for size 1. So it's saying that we can't, oh, we've got to go to a size 1. That's what we're using anyway. See, it says following selection for size 1 only. That's what we're using. So go down there, and it's got 11.4 to 12.1. Will that work? No. By only 0.05, it's too small, right? We've got to go to the next one, which is a 12.2 to 13.7, which is what? Very good. B22. Bingo! Oh, different game. Okay. All right, so now we have another size 1 starter, right? Except this time we're going to the 7.5 motor, and it's got a service factor of 1.25 and a nameplate FLA of 10 amps. So let's go back. Wait, we don't even need to go back, do we? We know that size 1 is going to be chart 15, right?
Yeah.
Okay. Let's go to 3 thermal units. We're using a size 1. We've got to look up, are we going to look up 90% of 10 amps? 9 amps? No, it's a 1.25 motor, so we can use the full nameplate ampacity, which is 10 amps. So all we have to do is go down this column to 10 amps. And what heater element is that? B15.5. Very good. B15.5. Okay, so our final, last big heater and starter is what size starter? It's a size 2. Big old number 2. So we're going to go back to our chart selection page. We've got to go down to number 2 now, and it says chart 58. So let's go to chart 58. That's not going to be on the next page. It's going to be farther back, much farther back. And I have it on page 248. No, I don't. 249.
It's on pink page 31.
Well, the Square D booklet 11249. So table 57, is that the one we're looking for?
58.
Huh? 58. Oh, good.
But 57 is next to it.
It's right next to it. Let's use 58 though. It says 58, right? Okay, so we're using 58. It's a size 2, right? And it's how many amps? 19.95. And we're not going to take 90% of that because it's a 1.25 service factor, right? Okay, so we're going to go down to 19.25 and 18.3 to 20.2 is a B32. Is that correct? And you can see that this is a really good place to use a straight edge, right?
Absolutely.
Very good thing to have a little piece of paper to use as a straight edge. So now we're going to use a B what?
32.
B32. And it's that simple. We just selected the wire for the motor branch circuit. We selected the starter. We selected the wire that'll go in the upper motor branch circuit. We selected the overload heaters. We selected the disconnect. We have selected the fuses. We have selected the wires that are going to go from the auxiliary gutter, where the taps are, down to the disconnects, and we size the disconnects and the fuses that are going to be in them. The next thing we need to do is size the auxiliary gutter. But we're going to do that in just a minute. We're going to take a break here because we're way over what YouTube would like to see the length of this video at. So we're going to stop here and we'll talk about sizing the auxiliary gutter because that's a long discussion all by itself.